first question in which they say you have to calculate the number of neutrons in a nucleus of polonium. If you see this question, they have given us the mass number, which is the sum of the protons and the neutrons, and they have given us the atomic number, which is the number of protons in a nucleus. So definitely, how would you calculate the neutron? It's simple. You have to subtract this mass number minus the atomic number. And so mass number is 210. You'll subtract the atomic number, that's 84. So answer is 126. So that means the answer for the first question is 126, which means the number of neutrons in an atom of polonium is equal to 126. Question 1.2. A polonium nucleus is formed when a stationary nucleus of bismuth 210 decays. A beta minus particle is emitted in this decay. You have to outline with reference to beta minus decay that why bismuth and polonium have a different proton number. So remember, in the beta minus decay, a neutron changes to a proton inside the nucleus, and it therefore results in the emission of a beta minus particle. So that means one of the neutrons in bismuth is undergoing decay and turning into what? It's turning into a proton. So a particle is definitely released during this process, and that particle carries the extra energy and charge that is created by the conversion of a neutron into a proton. If you just see this equation, and you will see that a bismuth is changing to a polonium, and that is why, because a neutron is changing to a proton. And that is why you will see in this equation that a bismuth is 83 and polonium has atomic number of 84. So next question 1.3. They have given us the kinetic energies of the beta minus particles emitted from a sample of bismuth analyzed, and these beta minus particles, they have a range of kinetic energies. So the total energy released when each nucleus of bismuth decays to a nucleus of polonium is about 1.2 mega electron volts. And they have given us a figure 1 here, which shows you the variation of the kinetic energy of the number of beta minus particles with the decay frequency. So the question is that how does the data in the figure 1, it supports the hypothesis that a third particle is produced during the beta minus decay. So first of all, let's move back to the figure 1. If you just see this figure 1 here carefully, you will notice that there is a discontinuation in the spectrum, or I would say there's an energy gap, since our spectrum has just finished before it reached the level of 1.2 mega electron volts. So where is this missing energy? This suggests that there is a missing energy. This missing energy is actually which supports the hypothesis that there is a presence of a third particle which is electrically neutral, almost massless. So therefore, if it's electrically neutral and almost massless, so therefore it could be either neutron or anti-neutrino. Question 1.4. They say that this third particle is an electron anti-neutrino. You have to explain why an electron anti-neutrino rather than electron neutrino is produced during the beta minus decay. Now, before we move forward to this question, let us understand what is a lepton number. Leptons group of elementary particles that include particles such as electrons, muons, and neutrons. And each lepton has a specific lepton number. And most of the time we denote it by capital L. So remember, in particle interactions, this lepton number is conserved. So keeping this in mind, let us solve this. So you know that so therefore, the conservation laws tell us that if we suppose that there is a production of an electron and an antineutrino, then definitely the lepton number must be conserved. And if the lepton number is conserved in this whole decay, then definitely we can say, yeah, this is actually an electron neutrino. Anyhow, let's see this question here. So this is the decay process. We have a neutron which is decaying into a proton and an electron antineutrino. So you know that the neutrons and protons have a lepton number of 0, electrons have a lepton number of +1, and the antineutrinos, they have a lepton number of -1. So neutron 0, and it's decaying to a proton which is again 0, and an electron which has a lepton number of +1 and antineutrino, it has a lepton number of -1. So if I just see this equation, I try to balance out the lepton numbers on both hand side, I can see that the leptons are definitely conserved. So therefore, I can conclude that yes, an antineutrino is produced during this reaction. Next question 1.5. They have shown us a Feynman's diagram, and they say that a large tank of water is used as a part of an electron antineutrino detector, and therefore an electron antineutrino enters the tank and therefore it interacts with the proton. So the interaction is what? You have an electron antineutrino which is interacting with a proton in the water tank, and when it is interacting with the proton, we have a production of a particle Y and electron positron, so that's a positron. For this question here, if we want to see that what is this particle Y and what type of interaction is this one, we have to guess what is X and what is Y. First of all, see the charge conservation here. Before the interaction, we have a charge of +1, and after the interaction, we also have a charge of +1. So therefore, we'll say the charge is conserved. Let's move on to the lepton number. If I see the lepton number for this one, so therefore, lepton conservation, if I see the lepton conservation, initially, the total lepton before the interaction was -1, and after the interaction, it's also -1. So I can say, yeah, so this particle Y, it has a charge of 0 and a lepton number of 0. But let's suppose about the baryon conservation. In the baryon conservation, I can see that the total baryon conservation before the interaction was +1, and the total baryon conservation after the interaction is 0. The baryon number, if it should be conserved, it should be +1. So what do we conclude? That this particle Y, neutron, and the exchange particle involved is a boson which is negatively charged. Okay, question 1.6. They say that a positron that is produced in the interaction, it collides with a lepton in the molecule of water, and you have to describe the process that occurs when the positron collides with this lepton. And in your answer, you should identify the lepton in the molecule of water. See this Feynman's diagram and understand that positron is what? Positron is actually an antiparticle of an electron. And if it is an antiparticle of an electron, therefore if it interacts with an electron in the water molecule, what will happen? Just try to recall yourself with a process which is called as annihilation. So positron and electrons, both of them are having some opposite charges. So if they are having the opposite charges, they are going to attract each other due to the electromagnetic forces. And when they are going to attract each other, they are going to annihilate, collision. So what is this annihilation? Annihilation is actually a reaction in which a particle and the antiparticle collide and disappear, and they release energy during this process. So if you just see this question, there is an electron that collides with a proton, there is an annihilation, and there is a release of 2 gamma photons, and this is called as annihilation. Next question 1.7. They have given us a range of electromagnetic interactions, and they say the interactions for the strong nucleus is almost 10 raised to power minus 15, and for weak it's 10 raised to power minus 18. So the question is that whether the positron or the electron antineutrino is likely to travel the shorter distance in the tank of water before interacting. First of all, let us see the particle type. We have 2 particle type. One is the positively charged positron, and the second one is a electron antineutrino, which is actually a neutral particle. This positron will interact through electromagnetic interaction. Remember, electromagnetic interaction is by an infinite range. It will interact with the electrons and protons definitely. About electron antineutrino, it will interact through the weak nuclear interaction, so therefore it will only interact with the electron. So what is our conclusion? So we conclude that positron will travel a shorter distance. Why? Because it is interacting electromagnetic interaction, which is infinite range, interact with more number of particles, which are electrons and protons, and that also for a greater range. So they will slow down earlier. So that means it will travel with a shorter distance as compared to the electron neutrino, which is going to travel or in with weak nuclear interaction, and therefore it's not going to counter with more particle as compared to the positron. So therefore it will travel with a greater range as compared to the positron. So the answer is that it will be the positron which will travel a shorter distance. Next question. They have given us a reflective layer from a DVD, and they said that she uses the DVD as a transmission diffracting grating. There is a laser that is pointing incident normally on a small section of the diffraction grating, and therefore there is a vertical pattern of bright spots on the screen. So the question is that you have to tell them that what is the path difference. You know that they have told us that the light of wavelength lambda is illuminating the slit and it will produce the maxima on the screen. What is the path difference between the adjacent light is actually produced by the first order maximum? You know there is an equation for the path difference which says d sine theta is equal to m lambda. Since we are talking about the first order maximum, so therefore our m will be equal to 1. If m is equal to 1, then the first order maximum will become what? It will be equal to lambda. So therefore our path difference will be equal to the wavelength, which is question 2.2. They're asking us how light from diffraction grating forms a maxima on the screen. Now you have to understand about the constructive interference here. You know, whenever the waves from a slit, they fall on the screen at a certain angle, they superimpose with each other. When the waves superimpose, we have the constructive interference. What is constructive interference? Hold on and recall yourself that what is a constructive interference. Constructive interference is actually when waves align in phase, and that results in reinforcement and increase in the amplitude of the resultant waves. So this is what that gives us the maxima on the screen. Next question. They have given us two tables. In one table, they have given us a disk and the slit spacing. And the next table, they have given us the two types of the laser and the wavelength given about the type of light that is emitted from those lasers. They have asked us a question that you have to deduce the combination of disk and laser that will produce the greatest possible number of interference maxima. So for this question here, first of all, you should understand an equation for the diffraction grating, which says that d sine theta is equal to n lambda, and therefore d is what? D is the distance between the slits, theta is the angle to the maximum, n is definitely the integer to the next bright fringe, lambda is the wavelength of the light. So, and you know the number of slits per meter is equal to 1 over d. So if I am going to put this 1 over d in this equation for d sine theta is equal to n lambda, I finish up with an equation which says n is equal to 2d sine theta over lambda. So I can say that the number of slits is actually inversely proportional to the wavelength, and it's directly proportional to the distance between the fringes. I can conclude that number of fringes is directly proportional to the distance between the slits, and it's inversely proportional to the wavelength of the light. So can I say that the maximum order will come when I have the maximum distance between the grating and the minimum wavelength according to the equation I have. So I move back to the table which they have given us in the question, and from that table here, which laser has the I'll move back to the table and see which disc has the maximum slit spacing, it's disc CD, and which laser has the minimum wavelength, that's laser A. Which combination is going to give me the maximum bright fringes? It will be laser A, and the slit spacing should be CD, which is almost equal to 1.6. Next question. They say that a screen has a diameter of about 30 centimeter and is positioned behind the CD at a fixed horizontal distance of about 15 centimeter. The student plans to adjust the height of the screen until she observes the greatest number of spots, and the student predicts that using this arrangement, the greatest number of spots in the screen will be 3. Determine whether the student's prediction is correct or not. Now this question needs a little bit of the calculations. You know that sine theta is equal to L lambda over D, where theta is the angle of diffraction, m is the order of fringe, and lambda is the wavelength of the laser, and D is the spacing of the diffraction element. So we have the wavelength, we have the distance between the slits. So for the first order maxima, when n is equal to 1, I can calculate the theta angle, which come up to be 22.89 degrees. And similarly, for the second order spot, I know when n is equal to 2, I will just put down all those values and my angle comes up to be 53.13 degrees. So you know, according to the relation, I know that tan theta is equal to r over 15. That is the distance from that disk to the screen. So tan theta is equal to r over 15, and 15 is what? 15 is the distance from the central point to the top of the screen, which has a diameter of about 30 centimeters. So definitely the radius will be equal to half of 30 will be equal to 15. So that's why we say tan theta is equal to r over 15. So the first order spot, you know, we have 23 degrees as the angle. Using that, I can calculate that what will be my distance from the height, and it come up to be 6.32 centimeter. For the second order spot, the distance is about 20.96 centimeter. So these are the two lengths. So if you just see this diagram on my right, you see that from the 0 order to the first order, the length is 6.32, and from the 0 order to the second order, the length is 20 centimeter. So how many maxima are you going to observe? Definitely we are going to observe 1, 2, 3 and 4. So I can say that no, the student predicted that she will observe only 3, but according to my prediction, no, she will observe 4 of the maximum orders. So therefore, she will observe 4 number of maximum orders. Next question, figure 5, which shows you a spacecraft traveling towards a comet. The spacecraft has an array of blocks designed to capture small dust particles from the comet tail. Okay. To test the blocks before the launch, the spherical dust particle P is fired at right angles to the surface of the fixed stationary block. P has a mass of about 1.1 times 10 raised to power minus 9 kg, and it has a speed of about 5.9 times 10 raised to power 3 meters per second when it hits the surface of the block, and P comes to rest inside the block. The first question is that you have to find out the work done. You know, work done is what? It's equal to the change in kinetic energy. What is the initial kinetic energy? They have given us the mass, that's equal to 1.1 into 10 raised to power minus 9 kg. We know the velocity of the particle, which is also given 5.9 into 10 raised to power 3 meters per second. And therefore, I will say that my initial kinetic energy is 1 over 2 times mass times v squared. So the answer to this question will be 0.19 joules. Why? Because you know that initial kinetic energy is going to be calculated like this. What about the final kinetic energy? You know, in the final kinetic energy, as it tells us that P is coming to rest, so therefore V will become 0. When it is 0, so therefore our kinetic energies are lost and will have 0 as the final kinetic energy. So therefore, energy loss will be equal to initial kinetic energy minus final kinetic energy. Final kinetic energy is 0, so therefore energy loss is equal to 0.019 joules, which is almost equal to the initial kinetic energy. So therefore, the work done is equal to loss in kinetic energy, which is equal to 0.19 joules. Next question. So the block is a rectangular with an area of cross section 8 centimeters square and a thickness of about 3 centimeter. So there is a figure 6 which shows how the density of the block varies with the depth up to its maximum thickness. Okay. See this graph carefully. They have given us the density on the vertical axis and they have given us the depth on the horizontal axis. So the question is that you have to calculate the mass of the block. What we are given? We have given the area of cross section and the thickness of the block. Area of cross section is 8 times 10 raised to power minus 4 meters square and thickness is 3 times 10 raised to power minus 2 meters. First of all, let's calculate the volume of the block. Volume of the block is area of cross section times thickness, which will make up the volume as 2.4 times 10 raised to power minus 5 meter. And let us find the average density from the graph. Now, average density, how will you find it from the graph? If you just see this figure, the maximum density is 50 kg per meter cube and the minimum density is 5 kg per meter cube. So my average will be 50 plus 5 and divided by 2. So therefore average density will be equal to 27.5. How to calculate the mass? Very simple. Mass is equal to average density times the volume. So therefore if you just solve this equation, you will get the answer. So therefore our answer to this question is that mass is equal to 6.6 times 10 raised to power minus 4 kg. So next question. They said that there is, in another test, a spherical particle Q is fired at right angle to the surface of an identical block. Q has the same mass as P and is traveling at the same speed as P when it strikes the surface of the block. Q is made from a less dense material than P. You have to compare the distance traveled by Q with that traveled by P as it brought to rest. Now particle Q will travel shorter distance than P. Why? Because it has a bigger volume, and if it has a bigger volume, then what? It will experience a higher air resistance. So because particle P is formed from a more dense material, so therefore it will encounter a less resistance and it will likely to travel a greater distance before it is coming to rest. In other words, you can say they said that Q is made from less dense material. How is density is related to the volume? It's inversely proportional. So something which is less dense means it will have a more volume, as in the case of the particle Q. So more volume means what? More amount of air resistance experience. More amount of air resistance experience means what? So therefore it will travel slower as compared to the other particle, which is P. So therefore which one is going to travel? So therefore the distance traveled by the particle Q will be shorter as it will experience more air resistance, and the particle P will have less distance travel because it is experiencing, So what is our conclusion? Our conclusion is that particle Q, since it is going to experience a greater amount of air resistance, it is going to slow down earlier, so therefore it is going to travel a shorter distance. Particle P, it is made up of more dense material and will encounter less air resistance, so definitely it will travel a longer distance. Let's start with question 4. See this figure for 7 and take a moment to read this question. So figure 8 shows you the forces which are acting on the pole. There is a force U which is acting at point Y, and this is making an angle theta with the vertical. There is a force D of 53 newtons which is acting at point X, and this is perpendicular to the pole. And there is a weight of 31 newtons, and this is acting at the center of the pole. Question is that you have to determine using the scale diagram the angle theta and the magnitude. So you have to draw a vector diagram of the three forces: 31 Newton force, the force D of 53 newtons, and the force U. And then you will use a ruler and a protractor to measure the angle and the magnitude. So therefore, U has a magnitude about 79 newtons and angle is about 25 degrees. Question 4.2. There's a figure 9 and it shows you figure 9. So let us see figure 7 and figure 9. In the figure 7, the pole is tilted, and in figure 9, the pole is horizontal. If you see figure 9 carefully, at point Y, there is a force V, and second force which is acting on this pole is the weight which is acting at the center of the pole. If you just see this forces carefully, W is still vertical S is still perpendicular to the beam. So therefore, the force V has to balance force S and the weight in order to keep this pole in equilibrium. So therefore, V must increase to maintain equilibrium. Question 5.1. You know, momentum is equal to mass times velocity. So if I just rearrange this formula, I know velocity is equal to momentum over mass. In this question, the estimated value of the person walking with the same speed as the speed of the ship is 1 meters per second. Momentum is given in the question, which is 1 times 10 raised to power Newton second. Mass is equal to 1 times 10 raised to power 7 divided by 1. So approximately mass is equal to 1 times 10 raised to power 7 kg. Question 5.2. According to the Newton's second law, it tells you when the water accelerates in the opposite direction. According to the Newton's second law, remember that the thrust causes the water to accelerate in the opposite direction. And third law tells you that every action has an equal and opposite reaction. So therefore, this propeller exerts a force on the water and that causes the ship to move in the forward direction. So that means an equal and opposite force to the accelerated water. In context of the conservation of momentum, so in order to keep the momentum of the ship and water system constant, in context of the conservation of momentum, the momentum of the ship and the water system is constant until acted upon by external forces. So therefore, the thrust which is generated by the propeller is compensate for the external forces. So it allows the ship to maintain its momentum and move forward at a constant speed. Figure 12, please have a look at this question. Thrust. So you know the introduction of the air bubbles causes a decrease in the mass of water being accelerated per second. This decrease of mass leads to reduction in the thrust. This air bubble also creates an insulation, and this insulation reduces the frictional forces between the hull and the outside environment, that is water. As you know, for a constant momentum, drag must be equal to thrust. So if you have a low drag force, that means you need a lower thrust. So therefore, we need less fuel to create the less amount of thrust. Hence, it saves the fuel. Question 6. A battery has an EMF of 5.3 volts and negligible internal resistance. What does it mean by EMF? EMF is the charge which moves through the battery and it gains 5.3 joules of energy per coulomb. Question 6. In figure 13, they have shown you a circuit which has an ideal ammeter, non-ideal voltmeter. We have to show that the reading on the ammeter is approximately 7 milliamperes. So the EMF flowing across the 640 ohm resistor is what? Its total EMF minus the reading on the voltmeter which is across the other resistor. So 5.3 minus 1.05, that's equal to 4.25 volts. Using this formula, V is equal to IR. Current is equal to EMF divided by resistance. EMF is 4.25 and I divide it by resistance, which is equal to 640 ohms. And that's equal to 0.0066 amperes, and approximately that's equal to 7 milliamperes, hence shown. Now you have to show that the resistance of the voltmeter is approximately 300 ohm. What is the given information? We know the total resistance, which is about 1.59 ohms, the resistance across the 320 ohm resistance, and we want to find out the resistance of the voltmeter. In order to calculate the equivalent resistance, remember the formula for resistor in parallel. 1 over equivalent resistance is equal to 1 over R1 plus 1 over R2 and so on. Substituting the values, I came up with the answer which says that R is equal to 300 ohms. Question 6.4. The voltmeter is connected across the battery terminals. You have to calculate the power dissipated in the voltmeter. Internal resistance of the voltmeter is 300 and the voltage across the voltmeter is 5 volts. You can use this formula, power is equal to V square over R. substitute the values, you will find the answer for the power, which is equal to 0.0833 V square over ohms. Converting it to watts, you just have to divide it by 1. So therefore, power is equal to 0.0833 watts. 6.5. They are asking us why the sum of these voltmeter readings does not equal the EMF of the battery. Remember, the position of the voltmeter in the circuit affects the current because the voltmeter internal resistance alters the total resistance in the branch it connects to. So that means if there is a change in the resistance, there is a change in the current according to the Ohm's law. Question 7. What is meant by modal dispersion? Modal dispersion is the spreading out of pulses of light in an optical fiber. And this happens due to the multi-modes or paths that light take within the fiber. And this is more noticeable in larger cores because light traveling down the core axis, it does travel shorter distance compared to the light which is experiencing total internal refraction. As you can see in the diagram below. In the first diagram, modal dispersion is seen when the light takes different paths. Next question. Have a look at this question. They are asking us to find the velocity. Since they have given us the angle of incidence, the length of the optical fiber, which is given as 10 kilometers, we'll convert it into meters, multiply it by 1000. By multiplying it by 1000, time of the pulse is also given. So simple, velocity is equal to distance over time. So 10,000 divided by 5.225 times 10 raised to power minus 5. So that's equal to 1.9 times 10 raised to power 8 meters per second. Therefore, the horizontal component of the velocity is equal to 1.9 times 10 raised to power 8 meters per second. Question 7.3. The frequency of the blue light is 720 terahertz. You have to calculate the speed of the blue light in the core of the optical fiber. Frequency of the blue light is given. The angle of incidence is 30 degrees. Sine of angle of refraction is 0.3390 and the refractive index of the incident medium is 1. Now let us see how do I get the sine of angle of refraction. In the figure 16 graph, you can see at the frequency of 720 terahertz, the sine of the angle of refraction is 0.3390. After this, I will simply use the Snell's law. I will put the values and find out the refractive index of the second medium, that is N2. And this refractive index of the second medium comes up to be 1.475. So velocity is equal to C divided by N, where C is equal to speed of light and I divide it by N, which is equal to 1.475. Therefore, the speed of light in the core of optical fiber is 2 times 10 raised to power 8 meters per second. 2 pulses of monochromatic light are incident other of the red light. So with the reference to the refractive index, why the red light has a shorter transit time than the pulse of blue light. Remember, what is refractive index? It is how much the speed of light is reduced when it is passing through a medium compared to its speed in vacuum. So a high refractive index means what? It will slow down more and therefore it will have a longer transit time, which happens in the case of blue light. Red light with a lower refractive index travel faster and has a shorter transit time. Question 7.5. You have to suggest one reason why the difference in their transit times may not be the same as in question 7.4. They are talking about chromatic dispersion here, which is a phenomena in which different wavelengths of light travel at different speed through a medium. Hence, red light and blue light, they are having different wavelengths. So therefore, they will experience different level of chromatic dispersion in the optical fiber, and hence their transit times will also be different.
For tutoring and resources, log on to www.physicsonlinetuition.com.